Hello friends, welcome to the week 10 summary of NCER course under NPTEL 2019. So without taking much time, we are moving towards the first topic, that is battery basics. There are electrochemical devices, electrode phase, electrolyte phase and charge transfer, and there is energy storage devices. So what is battery? We have to study that. So what is electrochemical device? It uses the anode and a cathode, and between them there is electrolyte and there is an external circuit. So electrolyte should have good ionic conductivity and poor electronic conductivity. This thing is often asked in the examination. You have to remember that at anode oxidation takes place and at cathode reduction takes place. Now for anode oxidation, that is loss of electrons, and cathode reduction, that is gain of electrons. There is a standard electrode potential. So in the between, for standard hydrogen electrode, the value is 0.00. This question is often asked. And what is energy storage device? Fuel and oxidant are stored within the device. And what is energy conversion device? Fuel and oxidant are stored external to the device. So what is a cell? A single electrochemical unit, that is one anode, one cathode and one electrolyte. And battery, a collection of cells in series or parallel. What is a primary cell? It is a single use power source. And secondary cell, it can be recharged again and again. So in thermodynamics we study cell voltage, and kinetics we use cell current. So what are cell characteristics? Capacity, total charge in cell coulombs or ampere hour. Voltage, current, that is power equal to V into I. Energy equal to power into time. So what are conclusions? That battery have specific parts that can have dramatically opposite functions. The electrochemical series is the starting point to understand battery voltages. Primary and secondary batteries are both commonly used. Now there are some battery testing and performance. So there is battery testing diagram shown: anode, electrolyte, cathode, load, voltage, ampere, voltmeter and ampere meter, and electronic load can be programmed. Now what is C rate? The rate at which the battery is discharged or charged relative to its capacity is known as C rate. So the rate at which the battery is charged or discharged relative to its capacity is known as C rate, and 1 C rate equal to discharge or charge in 1 hour, 2 C rate discharge or charge in 1/2 hour, 5 C rate discharge or charge in 12 minutes, 0.1 C rate equal to discharge or charge in 10 hours. Generally for the C rate, what we have to do, we have to divide the 60 minutes by the C rate. That is, for 1 C rate, 60 upon 1, that is 60 minutes equal to 1 hour. For 2 C rate, 60 upon 2, that is 30 minutes equal to half hour. And 5 C rate, 60 upon 5, that is 12 minutes. And similarly 0.0 C rate, that is 10 hours. Now what are terminology associated with use? State of charge, percentage of maximum capacity that is remained unused, and depth of discharge, percentage of maximum capacity that has been discharged, and life cycle. Cycle life, number of cycles before the battery fails to meet performance specifications affected by depth of discharge. Now there is a graph showing a comparison between two cells, between voltage and current density. It is clear over here. The cell A is represented by that is C rate, indicates the rate at which the battery is being charged or discharged relative to its capacity. Charge discharge curve typically shows steady performance of batteries excepting close to the fully charged and fully discharged conditions. And the polarization curve enables comparison between batteries from perspective of power delivery. There are some common types of batteries, that is prismatic cell. This is lead acid battery. This is rechargeable. It is high current density and it is toxic. There is nickel metal hydride. It is also rechargeable, non-toxic, replace alkaline and NiCd, no memory effect, high capacity and can self-discharge. There is nickel cadmium. It is rechargeable, high life cycle, reliable, lower capacity than NiMH, toxic and memory effect. There is lithium ion. It is also rechargeable, lighter than NiMH, better energy density, may self-discharge. There is lithium iron phosphate. It is rechargeable, high life cycle and stable chemistry, may not deliver as much as current as other chemistries. There is alkaline, non-rechargeable battery, inexpensive, may not deliver as much as current. There is carbon zinc, non-rechargeable, very inexpensive, very low energy density. There is lithium, non-rechargeable, high energy density, lightweight, expensive. So conclusions are, there are wide range of battery types. These batteries differ from each other in terms of capacity, environmental friendliness, current density is supported, and life cycle. And careful analysis is needed to match a battery with specific end use. Now we are throwing some light over the lithium ion batteries. Lithium, one of the most electropositive elements, lightweight, 0.53 gram per centimeter cube, environment friendly. So there is dendritic growth of lithium. Porous structure that grows on anode with each recharge cycle can result in an internal short circuit. Now there are some conclusions that lithium metal based rechargeable batteries can develop internal short circuit with repeated cycling. Lithium ion batteries overcome these issues. Intercalation and host compounds make lithium ion batteries safe. Homolume of electrolyte important is determining electrolyte stability window. Now I am going to take some important key points from the week 10, so you have to listen them very carefully. That batteries help in moderating the difference between demand and supply across the day by storing and releasing energy as required. And electrode reactions that occur during discharge are reversed during recharging in a secondary battery. And in the standard electrochemical series, the potential corresponding to hydrogen electrode is set to 0 volt arbitrarily. And lithium metal was used as the anode in early version of rechargeable lithium based batteries. So thank you very much for taking the week 10 summary. Thank you very much for spending your time. See you in week 11 soon, very soon.